All right. So suppose you invest P dollars at an annual rate of 6% compounded daily. How long does it take to increase your investment by 50%? And then B, how long does it take to double your money? So let's head on through that. We want to increase it by 50%. So let's, it doesn't tell us how much we have, but let's just call P1. Um, and so if we invest that $1, then to get 50%, we need to end up with 1.5. So that's our final amount. Our initial is 1, and now it's at 6%. So 1 plus our 0.06 divided by the period, and the compounding period is going to be compounded daily, so divided by 365. Now that to the 365th power, just for the compounding period, and that times t, for figuring out how long will it take, how many years will it take to do this. So let's go ahead and start rolling on through. And we get 1.5 is equal to 1 times, and so I'm going to drop out the 1 here, but 1 times 1.0002 to the 365 t power. Okay. Now we've got a couple different ways of doing this. One is you can do exactly what we did originally on this top problem. We took the log of base 10 just kind of arbitrarily, but took the log of both sides, and that was able to get us to our answer. And you can do that again, but I want to go ahead and practice using our change of base. So let's change this into logarithmic form. So I've got log base 1.0002 of 1.5 is equal to, what is that going to be? Is equal to 365t. 365t. All right. Now, if we were to convert this into using change of base, then this is going to become, write it in red now, so log base 10 of 1.5 divided by log base 10 of 1.0002 is equal to 365t. Okay. Now for here, go ahead and use your calculator. It ends up being right around 2027.53 equals 365t. Divide each side by 365, and t ends up being right around, t is right around, or approximately 5 point, is that 5.6 years? Let's go ahead and double check. I'm kind of going off my notes right here, but let's double check what that'll be. So if we have, where'd my calculator go? There it is. Log base 10 of 1.5 divided by log base 10 of 1.0002. That gives us the 2027.5, and you can round up 5.3. Now divide that by 365, and we get, 5.55, so right around 5.6 years. All right. I think earlier we rounded, right here, this guy rounded. So if you hadn't rounded back here, I think you end up with something closer to 6.9 years, something right around there, because we did round at this point. All right, so what about doubling our money then? How long till we double our money? And you know what? We are kind of short on some space. As you're going through, you're going to go through the same process as you did right here. Just this time you're going to end up with, so I'm going to kind of jump ahead and go back in the video if you need to see how we did this, but this time instead of increasing it by 50%, we're going to double it. So we need 2 equals that same setup, so equals 1.0002 to the 365t. And as you work through this, you should end up with something with t being right around 12 years. Either if you use our original number, that's if you use the original number. T should be right around 9.5 if you're using 1.0002. And if you didn't round it off, so it's 1.00016, then it'll be closer to 12 years. So look at how big of a difference. That's actually a great point right there. Look how big of a difference just rounding it off from 1.002 to 1.00016. That makes quite a big difference. Quite a big difference. And hopefully that makes sense. Why? Because, well, we're having it to the 365th power, and then that times t as well. So does make a big difference. But hope that helped. And all right, see you in the next video.